So does it mean that you are implementing this artifact store completely on your side, or are there also any integrations with already existing maybe dataset catalogs or something?
Feature stores, maybe.
It's like plugins. We don't think of this as feature stores. I think this is really interesting. So what comes out of internal machine learning pipeline steps, we don't consider oftentimes as features. I think you can also consume from a feature store. So we have standard integrations into S3 and Azure. We don't take over that, just to answer your question. So it's open source. It's a plugin system. So actually one of our early adopters who still uses a lot at massive scale, they actually used a completely independent artifact store. I still don't know what it is. It's an internal artifact storage system. And they just plugged it in one day, actually, by writing a class in Python. And this was for them such a big win. Like they switched over their entire MLOps platform just because of that reason, because they have these use cases. So we have seen many use cases like that.
Because also why I ask is because like usually artifact storage and artifact versioning is also part of experiment tracking solutions, right? So most of them have this. So if I would use ZenML, for example, as a pipeline orchestrator or authoring solution, in this case, framework, I don't need this, right? I don't need an experiment tracker to do this anymore.
I think experiment trackers do a slightly different function that we don't want to do. So I think experiment trackers do a lot of work around visualization and categorization of specific ML-specific artifacts that I think is still very valuable. So, I mean, you guys know that more than us. Oftentimes we are used with MLflow or Neptune as well, right? So we don't solve that problem that you guys solve. So what we use the artifact storage for is reproducibility, is caching, is faster execution of things. It's not necessarily cataloged in a way that it's an experiment, right? So I think you still probably need an experiment tracking layer, and we encourage that because we don't actually want, I mean, if we started doing that, we'll start building a known Frankenstein solution. So we don't want to do that. So we actually hand off to MLflow or Neptune or Comet or whatever. And oftentimes these things are used. Obviously, there's a redundancy sometimes in data artifact storage, maybe. But usually, I think the experiment trackers also focus on the inner training loop. So, for example, if you have a training step that is, making a loss go down, so we don't track that, right? That is internally within a step that is the experiment. So we track across steps. So it's slightly, we find that it's quite distinct oftentimes.
What's also interesting about this outer loop is that we can enable new business cases, like, for example, making an audit. What happened? How was the model trained? What was used? That's detailed then in the experiment tracker, but we can show you the whole journey from the start, how the model was created with what and where it was deployed. So that's a huge opportunity, what we are thinking about now.
What I was saying is that maybe this relation around artifact is similar to experiment tracker and feature store. So in experiment tracker, you will know that this model used this artifact, and this artifact is in feature store, and it is how you can get it. So I think in this case, it can work in a way that ZenML can reproduce it, right? But you will have the connection. You will understand from experiment tracker that in order to reproduce this model, this experiment, it is the pipeline, it is the artifact that done it.
Or you can even warm start. You can the steps before are cached, and then you can just like change some parameters and run it again from half of the pipeline. That's also really nice.